What do you think? When electron is added to an isolated gaseous atom, energy is released or energy is absorbed? You must be wondering what your answer should be. Let me tell you, both the things are possible. When addition of electron to the atom is a favorable process, then energy is released. That means when electron addition is a favorable process, stability is increasing, then it is an exothermic process, energy is released. And when addition of electron to an atom is not favorable, that means if already stable atom is getting electron and it becomes unstable, that means it doesn't want to gain electron. All right. So electron gain enthalpy means the energy absorbed or emitted when electron is getting added to an atom. All right. So electron, this energy absorbed or emitted on the addition of electron is known as electron gain enthalpy. Previously, we used to call it as electron affinity. So, electron gain enthalpy could be a negative value or could be positive. When it is positive only for few elements. Which are those elements? All noble gases in group 18, they have already have a stable configuration. They already have octet complete in their outermost shell. So, see, they do not want electron, right? So, what happens when you add electron, they resist. They do not want to get an electron. So, you are forcibly giving an electron. So, that means the process is endothermic. That means you have to put in extra energy to add electron to noble gases, helium, neon, hydrogen, krypton. All of them have positive electron gain enthalpy value because the process of addition of electron to these atoms is endothermic. All right. So electron gain enthalpy for them is positive. Now there are certain atoms like nitrogen, beryllium, magnesium which have a stable configuration. Nitrogen has half filled subshell, beryllium, magnesium has fully filled outermost subshell. So they do not want to gain electron because they are already stable. When you give them electron, they get unstable. So they do not want electron, and addition of electron is an endothermic process in nitrogen, beryllium, magnesium along with noble gases. So all these elements have positive electron gain enthalpy values. Other than them, other than them, all of the elements have negative electron gain enthalpy. That is something interesting, right? Usually what we think is metals want to lose electron, but electron gain enthalpy for them is also negative. That means when any atom adds is getting added a electron, then the process is exothermic. So electron gain enthalpy value of elements other than noble gas, nitrogen, beryllium, magnesium have a negative electron gain enthalpy. And what is the trend? In the periodic table, you must be wondering what is the trend. Down the group, electron gain enthalpy is increasing or decreasing. Down the group, if you go, electron gain enthalpy is decreasing. Across the period, electron gain enthalpy value is increasing. All right. So just remember the plus and minus sign in electron gain enthalpy value just means if plus sign is there, that means the process of electron addition is endothermic. If electron gain enthalpy is negative, that means the process of electron addition is exothermic. All right. So if you go down the group, the value of electron gain enthalpy becomes less and less negative, and across the period it becomes more and more negative. So which element has the highest electron gain enthalpy? That is chlorine. Chlorine has the highest electron gain enthalpy in the complete periodic table. So what is the trend? In group 17, all of the elements have 7 valence electrons. If they get extra electron, it is the happiest moment for them. So that's why the electron gain enthalpy of group 17 is most negative, means they will emit energy the maximum on addition of electron because they are happy, right? So group 17 has the most negative electron gain enthalpy, and in group 17 what is the order? Fluorine, chlorine, bromine, iodine. What? Chlorine has the highest. We spoke that across, if we go down the group, electron gain enthalpy value is getting less and less negative. So, but in fluorine and chlorine, chlorine has greater electron gain enthalpy. That means more negative electron gain enthalpy is for chlorine. So chlorine has highest electron affinity. Electron affinity is highest, as well as electron gain enthalpy is most negative. So both of these things are highest for chlorine in the complete periodic table. Similarly, if you go in group 16, so the second element in P block, let me tell you, I am telling you very secret thing, right? You must remember this. In P block, the second element in each group has the most negative electron gain enthalpy value. Remember this. This will help you. In P block, every second element has the most negative electron gain enthalpy in its group, right? As in group 17, chlorine has the most negative or the highest electron gain enthalpy value or electron affinity. Similarly, in group 16, sulfur has more negative electron gain enthalpy than oxygen. Similarly, phosphorus has more than nitrogen. So this is how the trend is, right? Just remember these things. Sulfur has more than oxygen, then decreasing order. So these all things are there. And what is the relation between electron affinity and electron gain enthalpy? The main difference is the sign difference, and only if you see numerically there is a slight difference in electron gain enthalpy and electron affinity value, which has been explained with this relation, that electron gain enthalpy equals to minus of electron affinity minus 5 by 2 RT. Alright, so this is the slightest difference. Apart from this, only the sign difference is there. If electron gain enthalpy is negative, electron affinity is positive. So that's it.